How can we make things easier, more efficient using robotics, automation? And how does that relate to healthcare facilities? Well, my own background is in automation, artificial intelligence, control engineering, applied to several different contexts, including smart buildings. So what I'd hope to do today is to give a bit of a picture of where some of this state-of-the-art lies with respect to automation and how that can apply to waste management, sustainability, and efficiency savings in the context of healthcare facilities management. So I wondered where to start in terms of an intro. So let's run a scenario. All familiar with Marvel, Jarvis? So imagine the scenario where you can say, Jarvis, pull the IoT records for the main lab from March. Give me temperature, humidity, and then run the video analytics. Tell me how many people were in the lab, what they were doing, and then use that to fit a model that will allow me to predict the impact of people's activities and behaviors on the HVAC systems. As we all know, HVAC systems, huge consumers of energy, not just clean room applications, but buildings and facilities in general. So then the AI comes back and says, okay, certainly, done. Model is a good fit, over 80%. And then you say, okay, design a controller. Give me an optimal regulator that will minimize energy and maximize participant comfort. Goes off, yeah, designed it, there we go. And then you say, okay, let's run a trial. Let's hook this into the building management system and see how it performs. So science fiction, yeah? Science fiction or science fact? Well, no, that was a couple of weeks ago in the Net Zero Industry Innovation Center in Middlesbrough. So we've got some collaborative projects looking at how we can deploy AI in the context of smart energy and building management. Collaborative work, cross-funded by the UK government and the Saudi government. And we're running pilots not only in the UK, but in smart buildings in Abu Dhabi and smart buildings in Neom, the futuristic city that is currently under construction in Saudi Arabia. So how exactly does this work? How does it fit together? And what's the links with things like ChatGPT? And what are the links with smart vehicles and driverless vehicles? And what are the links with smart robotics and how we could use robotics to, for example, learn how to process a complicated waste stream? So that's what I'll try and do today, give a bit of an overview. So kind of formal introduction. We know sustainable access to clean energy and water, essential for public health, and aligns well with multiple UN Sustainable Development Goals. We know that in the UK, healthcare facilities, major consumers of energy and water. And if we can make a bit of an imprint and a reduction in the amount of waste of even, say, 5 or 10%, that can have significant returns and impacts on the UK's climate goals, but also on the costs of running the facilities themselves. So intelligent building management systems, the Internet of Things, cloud-based tools, AI-driven optimization, there's loads of buzzwords flying around at the minute. And what we're interested in at Teesside is not just how we can push the state-of-the-art research-wise, but how we can start to translate that into practical tools, products, and services that people can actually use and glean benefits from. So we're looking at impactful research. Now, what I'd like to do, take a bit of a deeper dive into digitalization and AI, and just give a high-level introduction. So what do we mean by a convolutional neural network, and how could we use it? What is a spiking neural network? What is a large language model? And how does this relate to things like agent-based AI and ChatGPT? And above all, how does this then work itself down into advances which we can actually apply in the context of infrastructure and manufacturing operations, refueling and recycling? So lots of discussion, sustainability and net zero. Arguments on both sides, but ultimately we know the world is in turmoil. Geopolitical upheaval, rising global temperatures, toxic smog around our cities. This was Delhi last year. All the schools were closed in Delhi. Valencia, flash floods, over a year's worth of rain in less than 24 hours. Unusual events, weather patterns, which are indicative of wider problems. And problems to do with waste and consumption of fossil fuels. Now, we know the world still uses in 2024, over 80% of our energy comes from fossil fuels, so we can't switch them off. We need a managed transition. And it's going to be very complicated because we have to work out how we can do this in such a way that it doesn't blow the bank and we don't think in a magical way and try and use technology which is not yet fit for purpose. And we have to make sure that we do it in a way that kind of makes sense. And we know there are lots of abundances, food, clothing, plastics in the developed world, significant shortfalls in the less developed world. Rising costs and problems associated with traditional ways of life. So we need change. Change is slow and painful. How that turns, or what that looks like in terms of research and innovation, there are no magic bullets. And we can't just magically go from where we were 10 years ago to a complete green, carbon-free society in 2030. It's not going to happen. But we need to explore pathways and innovation, technological advancements, coupled with other advancements. It's not only people, not only technology, but people are involved as well. But let's refocus and start to look again at some of the technologies and how that relates to healthcare and facilities management. We know electric heat pumps, hydrogen boilers, district heating. These are all going to play key roles in the decarbonisation of the built environment. Built environment throughout Europe, it's responsible for around 60% of energy consumption. So that includes all kinds of residential, commercial houses, industrial facilities in terms of not the manufacturing energy itself, but the operation of the facilities that house them. And of course, hospitals and healthcare centres. So we know reduction and decarbonisation is going to map its way out across hospitals and healthcare as well. So if we start to look what has been effective and what hasn't been effective in other residential sectors, that can give some indication, because in the context of healthcare, we need reliability, we need dependability, and we need cost effectiveness. And that's the same as in other sectors. For example, manufacturing, critical manufacturing operations, just-in-time constraints. So what solutions have been adopted in the industrial sector, and how are we progressing in terms of the technologies in those sectors? And I'll extract one or two examples as we move through, which can show and give some insight into how companies like KP Snacks and Billingham are starting to think about how they can adopt hydrogen in terms of their plant operations. And of course, this would ask other questions. Well, what's hydrogen got to do with AI? Quite a lot, actually, as we'll see. So the context of where we're coming from. Teesside University, you may have just heard, won Modern University of the Year very recently. So we're on the front foot in terms of digital technologies. We're on the front foot in terms of net zero, and we're on the front foot in terms of health and social care. Those are our three principal research pillars. So we recently opened the Net Zero Industry Innovation Centre, a multi-million-pound facility, which is, its mission is to be a serious research facility linked into our local industry cluster to explore reliable and feasible options for decarbonisation. Because if you know anything about Middlesbrough, you'll know that our nickname is the Smoggies. And it's a sad reality that the industrial cluster on Teesside is, by square metre, the most polluting area of the whole United Kingdom. So if we can decarbonise the Tees Valley, we can decarbonise anything. So that's our remit. And where does digitalisation come in? Well, if we look at automation and how that's advanced, in tune with various revisions of the Industrial Revolution, we're starting to see that infrastructure digitalization, as well as automation within factories, down supply chains, is starting to give a lot of extra information and insights as to what's actually happening and how supply chains and manufacturing facilities are interconnected. This generates a huge amount of data, and we simply can't process it using humans. We have to use AI. And where we're starting to see advances is in deep machine learning and around the evolution of so-called artificial neural networks. So AI and automation, in general, refers to having a machine, and that could be a mechanical machine with levers and so on. It could be an electromechanical machine, relays, an old-fashioned industrial switch panel, or it could be software-based. Having a machine that mimics human or animal intelligence. We typically talk about AI in terms of mimicking human intelligence, but often we're also interested in mimicking animal intelligence as well. And it actually encompasses a wide range of technologies: machine learning, natural language processing, computer vision, and it's used in a huge amount of applications. So modern AI, all kinds of different buzzwords. It seems that the landscape is continually shifting, and in fact, it is. Biggest developments: large language models, taking text-based input, processing it, and extracting meaning, and getting insight into encoded information. We can upload a book, and the large language model will attempt to understand the book, key parts of the storyline, and how various structures within the document fit together. That's all a large language model does. ChatGPT uses a large language model, but it also has lots of other components as well. It has components related to agents, which use large language models to process input, but then we have an agent, which uses reinforcement learning. It learns by trial and error, using statistics, and updates internal structures and a knowledge base about how it perceives the world, or the interactions it's having with the world. And we can then apply generative AI, which will use an agent and information fed to it from a large language model to try and act on commands that the agent is trying to issue and generate content which makes sense to the people it's interacting with. And a large language model is not the only way that we can process information: visuospatial information, images, videos. We can use convolutional neural networks to extract the meaning from images and videos and try and strip it down to its basic components. This is a cat. This is a dog. This is a person. This is a piece of workwear that we want to extract from a workwear stream. This is a clean piece of workwear. This is dirty. This is damaged. This isn't. We can build up knowledge by processing and learning from images. Other types of neural networks, different buzzwords, spiking neural networks, different ways to encode information, which are more like Morse code rather than pixelation. So how does this impact in terms of smart energy and facilities management? Well, we can start to look at digitalization in blocks of buildings. And in the context of previous work funded by Innovate UK, funded by Horizon Europe, we've looked at how we can apply digitalization and control to manage energy, integrate renewables within the context of large energy communities. So blocks of buildings, lots of participants, lots of users, how they interact with an energy system, and how their behavior and activity impacts upon the energy footprint of the building, and how we can optimally configure our facilities to match the behavior of the occupants. And this can be quite important because if you ask construction, civil engineers, architects, when a building is first designed, a number of assumptions are made. And everything at design time is procured and put in place based on original assumptions about how a particular place is going to be used. But then once the facility is built, once it's commissioned, and once it's put into operation, how it is used will often vary quite considerably over the life cycle of the building. Office changes, relocations of equipment, changes of management, changes of priority. Buildings are very, very dynamic things. And if we don't adapt to the way that buildings are being used, we end up with very, very inefficient use of the facilities themselves. And this applies in the context of any type of infrastructure that is designed and built by architects and civil engineers in marine infrastructures, ports operations. We can reduce energy footprint within the context of PD ports by around about 40% by making more optimal use of facilities, the rubber-tired gantry cranes, the ship-to-shore cranes. Understanding the logistics of what's actually happening in the port allows us to reduce energy. And decarbonization of the buildings themselves, moving away from kerosene and deployment of heat pumps. Significant reductions in CO2 emissions. Problem is, more connection onto the electricity grid. Larger demand on the electricity supply side. But this is where AI can come in. Understanding and learning how buildings are used, and then making sure that we dispatch and control the electric heaters such that we minimize the peak load on the distribution network. And solar integration, it's arguable, lots of arguments. I'm undecided myself about how effective solar is in the northeast of England. Very low yield. On the south coast, in France, parts of Spain, we're working in Abu Dhabi, India. Solar is perfect. It's maybe not so good in the northeast UK. But still, that still doesn't stop us carrying out research as how we can maximize the coupling between the panel and the load in real time. And this is where control can come in and help, an analysis of data. Now, if we want to see what we think really is the state of the art in terms of large infrastructure management, we can start to look at some of the projects that we're running in Singapore, Abu Dhabi, Saudi Arabia, and the UK. So using IoT, interact with sensors, interact with closed-circuit TV, which pretty much we find in almost all modern buildings, and interact with the building management system and the stakeholders. And we piloted a system in Teesside, IoT-based system, and started to run trials now in Abu Dhabi. And now might be a good time if we could show the video. Got a short video which shows processing of CCTV feeds in real time using convolutional neural networks. There we go. So that's me walking through the lab, the Intelligent Energy Lab in the Net Zero, geo-fenced areas, and real-time object and activity detection. So that's me, it's recognized me. It knows I was in zone 1. It can detect when I walk in and out of the lab. So real-time processing of information using CNNs, convolutional neural networks. So we start to overlay this in the context of facilities management. The idea here, we have to be cognizant of data protection and how and why we're using AI. But if we want to derive actionable insights from CCTV feeds, how many people are in a certain area at a certain point in time? How much activity are they carrying out? At what times of the day do we expect the largest concentrations of people? And we can process this information and start to build up predictive models. And this gives huge insights into how facilities are being used in real time, and what the footprint and what the effect is going to be on things like management of humidity, management of temperature, management of CO2 content in a particular area. And we can use this information to be a lot more intelligent about how we use a HVAC system in terms of the required airflows, in terms of the required heating or cooling of the air. We've shown through experiments that we can make significant reductions in the requirements for energy by adapting to the way buildings are used in real time. And in the context of shopping malls and residential accommodation in hot countries, this has a significant impact on carbon emissions. Okay, so moving on. I've just been told we should shift things on. So second thing I'd like to talk about just before we finish is AI in the context of smart recycling. And we're starting to develop a framework, a modern AI-based framework for how cobots can be used in the context of recycling. So very complex tasks, trying to recognize from a waste stream what different kinds of objects represent, what they are made of, how a robot could take them from the waste stream, how a robot can process them, partially or fully disassemble them, and use this in real time to support intelligent recycling. Workwear, garments, end-of-life electrical products, and end-of-life EV batteries. And working with another industrial partner, Altilium Cleantech, based in Devon, we've been exploring how we can use this architecture in the context of end-of-life EV battery recycling. Now, recycling of an end-of-life battery is a very, very complex operation. All kinds of plastics, graphene, copper, different metals, as well as lithium, cobalt, nickel, all of the critical minerals themselves. And batteries come in all kinds of different shapes and forms, in different volumes as well. So being able to teach a robot to process a waste stream of batteries in real time is seen as vital to unlocking our ability to recycle end-of-life batteries. And final application around how we can start to think about the use of hydrogen and only hydrogen in hydrocarbons. So repurposing traditional hydrocarbons, coal, gasoline, petroleum, and so on, and just using the hydrogen and related derivatives, ammonia, methanol, and so on. And AI and control play a huge role in understanding how the reduction of carbon from a traditional hydrocarbon affects the combustion process and the efficiency of the technology that's needed in its combustion. And if we look at an example from KP Snacks, huge heating units. We know we have large heating units in hospitals, CHP. We have requirements for generation of electricity and heat in the context of the operation of hospitals. We've worked with some in Brescia, for example. But here we have a large industrial heating unit which is involved in food manufacture. KP Snacks, very interested in decarbonisation, huge energy footprint, huge carbon footprint in the manufacture of McCoys. And I love a pack of McCoys. So if we can make them low carbon and still keep the price down, I'm all for that. So how do we move from a combustion unit like this in industry that runs on natural gas and a huge volume of it to a situation whereby it can run on hydrogen if hydrogen is available? We draw inspiration from the concept of the hybrid vehicle. It can run on petrol or diesel and also on battery. So we can design a dual fuel system and use AI to learn how we should control this dual fuel type system. And we've managed to show with KP Snacks that although the control problem is significantly more complicated, it's solvable with the help of AI and analytics. And we're prototyping a system that allows us to move from full natural gas over to full hydrogen dynamically as the hydrogen is available. So we need to wrap up there. Thanks everyone for listening. End message, what we're seeing here is examples of technology pushing the state of the art. Some of this is being successful, others not so successful. It's a very complicated picture, a complicated transition, but we need to keep up the sustained effort and pressure. And really, we're on the verge, in my opinion, of seeing transformations across different sectors involving AI, digitalization, and alternative fuels. And how this can impact the NHS, well, that remains to be seen. But there is a lot of potential there. So thank you very much for listening. I hope this has been useful in the context of your own work environments. Thank you.